Okay, so here's the screencast for worksheet 17 on macromolecules. First question, what is the type of linkage present in nylon and terylene respectively? We've gone through these in class, and you should know that terylene is an ester linkage and nylon is an amide linkage. So even though I may not ask you what is the monomer for these two, you should know what is the type of linkage formed, okay, to make these polymers. These two are the examples that you should know along with proteins. Let's change color. Okay, the monomer for vinyl chloride is this. I always don't like structural formula. I prefer to draw it out. So it will look like with two hydrogen to the first carbon. The second carbon has a hydrogen and a chlorine. Give the structural formula of polyvinyl chloride. Again, what you have to do is minus off one double bond, join it on both sides, draw it to the end. Okay, they didn't ask you to draw the a few repeating units, so even if you draw it in this form, it will also be accepted. Okay, but if you want to draw it out like this, usually you draw at least three repeating. Okay, so the three things still holds. Explain the meaning of the term non-biodegradable and the problems for. Okay, so non-biodegradable, I think in the notes it's also written that it cannot be broken down by organisms such as bacteria and other decomposers. Problem will be then how do we dispose it? When we dispose it, it will produce gases, toxic gases. We don't have place to store them. In fact, this is a very real problem for Singapore. Okay, in Singapore, do you know where our waste go to? It goes to Pulau Semakau. Okay, and the worrying thing is, well, when I visited them when I was a student, which is like years ago, in Sec 3, I think, I visited Pulau Semakau, and at that time, they already projected that by, I think, 2025 or 2020, they're going to run out of space in the landfill. They have 4 parts, I think, and 3 is used already. We are down to the one last quarter that we can use for the landfill, which is very worrying because our waste increases every year, but our space to fill those waste decreases every year as well. So the 3 R's is very important, and you should also try and educate your parents, because I think the older generation, their concept towards recycling, reducing, reusing is still not as strong. Okay. Next, okay, that was a digression. When polychloroethene, again, this one. Okay, you may not know that it's the same thing. Polychloroethene. So you must know what is chloroethene. Chloroethene is CCHHHCl. So it's the same as polyvinyl chloride. Okay, it's burned in an incinerator. A gas is produced which is strongly acidic. If this is mixed with ammonia, dense white fumes of ammonium chloride is formed. So what is this gas? This gas with ammonia, so X plus NH3 gives you NH4Cl. So what is X? It will be HCl. Okay, note that you are supposed to write hydrogen chloride and not hydrochloric acid because it's a gas. Okay, only when hydrogen chloride dissolves in water, then we will get hydrochloric acid. Okay, give one disadvantage of letting this acidic gas into the atmosphere. Okay, so first of all, acid rain, and you know the repercussions of acid rain as usual. You can write a lot of stuff. You can just say destroy forests, leach nutrients from soil, damage buildings, damage acidic metallic structures, kills marine life. Name 2 other gas produced when it is burnt. So HCl, what other gas? There's also carbon being present, so carbon dioxide. There's also hydrogen, so water vapor. Okay, next we move on to the assignment question. Perspex is manufactured from this as a monomer. Write an equation for the polymerization for the monomer to form perspex. Okay, so first you need to decide what is the possible form of polymerization. Is it addition? If that's the case, I need CC double bond. Or is it condensation? In which case, I need a carboxylic acid plus either a hydroxyl group or an amine group, right? So if you look here, you will note that there is a CC double bond here, but we do not have an acid group, nor do we have an alcohol or amine group. We have an ester group, but an ester by itself cannot polymerize, right? That's the end product. So it can't polymerize by itself. So you should know that addition polymerization is the way to go. How do you write an equation? So n amount of the monomer will form this polymerized form. Again, you remove the one of the double bonds, draw out the sides and bracket and put an n. So this will be the answer. The perspex monomer is actually an ester. Okay, just now we already said that it's an ester, which can be broken down into an alcohol and a carboxylic acid. What is the structural formula for these two compounds and name them? Sometimes students will miss out the second part. They just draw the structural formula and they forgot this other part where they ask you to name them. Know that it's 4 marks, so 1 mark for the correct structural formula, 1 mark for the correct name. Okay, let's see how to break this. Again, an ester has the C double bond O bond. How do I cut this bond? Remember, I cut it here. The C double bond O belongs to the acid, so let me just draw the acid. Okay, this is your acid. Then the other part, this will be your alcohol. So the alcohol is simply CH3OH. Since they ask you to draw the structural formula, so you should draw. Okay, they didn't ask you to draw the full display, so you can write, draw methyl groups like this. But note that you are connected. Okay, the connection here is a bit wrong. Okay, let me draw over in white ink. Why the connection like saying? Okay, let's try again. The first carbon has a hydrogen connected to it. Second carbon has a methyl group and a C double bond O OH group. Okay, so make sure that your carbon is joined to the carbon here. To name it, how do I name this? Note that the first priority is your acid, right? So it's something acid. How many carbons are there in the longest chain? In the longest chain, there's only 3 carbon. So it's prop, something acid. Okay, note that I have a double bond here. I think your answer is not exactly clear. It should be 2-methyl propanoic acid. Yes. Okay, so the answer should be 2-methyl propanoic acid. You may ask me, why is it that don't need to write prop 2 in? Because if it is the double bond is here, then it's not possible for it to be 2-methyl. Okay, since we specify it's 2-methyl, therefore the double bond is by default in the second position. Using only the compound below, a polymer can be made by the elimination of a small molecule. What is the small molecule eliminated? Okay, now note here that this is your amine, whereas this is your, it looks similar to your carboxylic group. This is known as your acyl chloride. Are you required to know that it's called acyl chloride? No, you don't need to. But I give this as an example as to what is a small molecule eliminated that is not water. Okay, and note that it is hydrogen chloride. How does this work? How does this work? Okay, let me scale this down. Copy, paste. Wonders of modern technology. Okay, so if these two compounds come together, what will be eliminated is this. Okay, and what will I get in return? It will join up like this. Oh, they're ugly. Okay, let me just move this closer. It will join like this, and HCl is eliminated. Okay, so this is how we get the hydrogen chloride. And okay, so here they say to show at least 2 repeat units, so draw 3 lah. Okay, here the person is a bit kiasu. They drew like 4. Okay, but know that you should draw at least 3. Name the linkage in the polymer. Okay, so what is the linkage here? The linkage looks familiar. Is C double bond O connected to a nitrogen. Okay, so this is a amide bond. What is the type of polymerization? There's only addition or condensation, and this is condensation. Okay, next we move on to a database question. Story of nylon. It is really like a story that is very long. So this is the kind of question that students will freeze during exam, like, oh my god, it's so long. Okay, but you can get through it by reading it carefully, highlighting as you go. This is what I did. Okay, so first, this guy, he developed the first nylon. So he used a diamine and a dicarboxylic acid to make nylon 6,6, like this. So when you see a structure, analyze it. Do you know how to read this structure? What is the linkage here? The linkage is over here. This is a amide bond, right? The number in the systemic name of each nylon refers to the number of carbon atoms from the amine. Okay, the number of carbon atoms from the diamine. So here, CH2 bracket 6, it tells me that there are 6 carbon, and the dicarboxylic acid. Okay, so since this is nylon 6,6, the first 6 came from the amine, this part. The second 6 came from this part. So how did I get 6 carbon? You must include the carbon and the acid as well. Okay, they give you another example just in case you don't understand. So here, bracket 5, so there's 5 carbon atoms here, including these 2 carbon, and the 8 in the middle here, we have 10. So it's nylon 5, 10. So that's how you name the nylon polymers. Okay, sorry, I think I'm having the beginnings of a flu, so my nose is like got some problem. Okay, anyway, this can be made from a single monomer. Okay, so nylon 6, know that there's only one number, so it's not made of 2 monomers. There's only one monomer, has an amine group at one side and carboxylic group on the other side. So it looks like this. Amine group on one side, carboxylic group on the other. Okay, and note that there's 5 carbon here and 1 more. So in total, I have 6 carbon. That's why it's called nylon 6. Other types of nylons were developed later. This is nylon X, this is nylon Y. This is the repeating unit. Okay, so here you see that the repeating unit consists of a diamine and a diacid. Here is the kind where there's an acid on one side and an amine on the other. Different types of nylon was used for different purposes. One of the limits to their use is that they cannot be used in contact to solutions with strong acid because they react to give their monomer molecules. In other words, strong acid will hydrolyze. Then back to the original monomer. Some uses of nylon are related to their melting points. For nylons made of 2 different monomers, they are affected by the chain length of the amine and the dicarboxylic acid. So we give you a few melting points. Nylons are useful because they are generally unreactive and can be made into very strong fibers. So very strong. To make fibers, they must have a relative molecular mass of very high lah. Okay. Disposal of used nylon, difficult to dispose because they are non-biodegradable. Can be disposed by burning at a high temperature, though both methods of disposal give off carbon dioxide. Okay, that means that they have a carbon footprint and is calculated by this formula here. Definitely you need to use this formula later, so studies first. Okay, how do we calculate? By considering the amount of carbon dioxide given off by each repeating unit of nylon. For example, nylon 6. We see that in each nylon there is 6 carbons, so we get 6 moles of carbon dioxide formed. Okay, technically this equation is wrong. It's not 6, it is 6N CO2. Okay, since there's N here. Okay, does it make sense? Name nylon X and nylon Y. Okay, let's go back to this structure. Let's count what's the number of carbon atoms here in the diamine. There's 4 carbon. Here in the diacid, I have 6 carbon. So this will be nylon 4, 6. Here, how many carbons are there? There's 10 here, 10 here, but there's still this carbon to take note of, so I have 11 in total. So this will be known as nylon 11. Okay, 2 marks here, so 1 mark for each correct number. Even if you write nylon 4, 5, it's still okay. Okay, given the structural formula of the 2 products, give the structural formula of the 2 products that form when nylon 5,10 is left in contact with a strong acid. So when it's hydrolyzed to the diacid and diamine. So note that the first number belongs to your diamine. The other number belongs to your diacid. Right, so let's try CH2. Since the first diamine has 5 carbon, it should look like this. Okay, the diacid has 10 carbon, but that's inclusive of the carbons at the side. Right, so the carbons that are in the center should be 8, so that I have 10 in total. I think the answer key is wrong. If it's nylon 510, then it should be the answer that I drew. Okay, it should not be 6 here. It should be 8 there. Okay, if you draw the full structure formula, it's also awarded marks. So you can either draw the one that I've drawn here, or you can write this version. The article says for nylon made of two monomers, the melting point is affected by the chain length of the diamine and dicarboxylic acid used to make the nylon. How is the melting point affected by chain lengths of diamine and dicarboxylic acid? Explain. Okay, so we need to go back to the table. Since they give us a table, we should use this, right? So first, you see that the chain length of diacid increases, melting point decreases. Okay, next, when let's compare the first and let's compare this one with this one, and you'll see that when chain length of diamine decreases, melting point increases. So that's your answer. Compare nylon 6,6 and nylon 4,6. When the length of the diamine has decreased, then we get a higher melting point. Thus, the shorter the chain, the higher the melting point. Okay, next we have the longer the carboxylic acid, lower the melting point. Okay, if we compare this with nylon 612, the difference in temperature is smaller, only 2, whereas this is 49 degrees Celsius difference. So we see that when with increasing chain length, the extent of decrease is lesser. Okay, I think it's a bit hard to expect that you can get this last point now. I think in exam we won't be so kekao because it's like quite long. So I think how I will mark it is, if you give data, that means you quote data, is 1 mark. If you give the correct trend here, each 1 mark. Okay, that's how you can mark your answer. Calculate the carbon footprint of nylon 6. Okay, so first, 1 mole. You just need to find the... Okay, I teach you how to do this huh? You don't know the MR of nylon 6. But you know that there are 6 carbon per repeating unit of nylon. So, do you know the MR? Okay, so this is not the number of mole of nylon 6, this is the number of mole of a repeating unit of nylon 6 in 1 kg. So you find the MR. Did they tell you the MR? Let me see. Oh, they didn't tell you the MR, so you are supposed to calculate yourself lah. Okay, anyway, you look at the repeating unit. 5 carbon, so 12 times 5 plus 3 hydrogen plus 14, 12 times 6, sorry, plus 16. Does it give you the correct answer? Yeah. Okay, so you get 113, 1000 divided by 113, so per kg, I get this number of moles times 6 carbon. This is the number of moles of carbon atoms. So the number of moles of carbon atoms will give you the number of moles of carbon dioxide. It times, this is the MR, 44, is it? Okay, so this is the mass of carbon dioxide. I get the number of moles multiplied by the MR of CO2. Since it's per kg, this is why here it is 1000 divided by the MR. Okay, so I get this mass or this kg. I would prefer to write it in kg. Okay, if you see that it can be written in kg, you should try and write it in kg. Makes things neater lah. Okay, so that's all. If you still have questions, please email me or sign up for a consultation slot for term 4 week 1 or week 2. That's all. Thank you.